Boys and girls, good morning. I hope I find you well this morning. I'm well. I hope you're working hard. At the same time, you're keeping safe. You're protecting yourself. You are also protecting your family. May I urge you to stay home and attend to your schoolwork. Avoid social gatherings. Maintain social distancing. Sanitize regularly. And make sure that you adhere to all the COVID protocols. Here we are again. We meet this morning. I want to take you through the topic of fractions. We know fractions is a very broad topic. I'll just cover a few aspects of fractions this morning. Up there, I have put a few terms which go with fractions. I'm sure by the end of this lesson, you'll be able to explain and understand these terms much better. When we talk of fractions, what are fractions? What is a fraction? When we talk of a fraction, we're talking of part of a whole. And what is a whole? A whole is something complete. It's something full. My body is a whole. My hand becomes part of my body. So it's a fraction of my body. If you talk of a lemon, which is not cut, that's a whole. You talk of an apple, which is not cut, that is also a whole. But when you cut a piece of it, then that is the fraction of that lemon. Right. When we talk of fractions, a fraction has two parts. As you can see there, we have a number up there and another one at the bottom there. These two numbers have names. The top number is called the numerator. The bottom number is called the denominator. Where do we get the denominator? Let us consider this rectangle. I may draw my rectangle this way. I may choose to divide it into 5 parts. Yes. These 5 parts, they represent the denominator. So whatever I'm going to shed here is going to be out of 5. The question can be like, how many parts are shaded? I'm just going to shed 2 parts of this. I've shaded 2 parts. So how many parts are shaded there? I've shaded only 2. So it's 2/5 shaded, or 2 out of the 5 parts. Remember, I said this whole represent the denominator. The parts that I've put here, all of them, they represent the denominator. And the parts that I've considered, that I've chosen to shed, they represent the numerator. I may also use a set. We don't have to use shapes all the time. I may also use a set. In my set there, I have put my 5 cups. I've put my 7 cups in that set. I may consider 3 of them. I'm going to shed these 3 of them. Then, what fraction is not shaded there? I'm just going to count those that I've left unshaded. So it means 4 out of 7 is not shaded. Let's keep in mind, we have the numerator there and the denominator. Right. We have types of fractions. A few of them, I've just put them up the board there. We have a proper fraction. Why are we calling this fraction proper? We call it proper because we have a small number out of a bigger number. It is proper for a son to be carried by a father because the son is smaller than a father. But it is very improper for a father to be carried by a son. Then this fraction will be called an improper fraction, where we have a bigger number as the numerator and a smaller number as the denominator. Right. From there, we see this one, where we have a whole number and a fraction. This is called a mixed number, where we have a whole number and a fraction. As we go on, you understand how an improper fraction becomes a mixed number, and how a mixed number can be an improper fraction. I'm sure from here you'll be able to classify these fractions. I'm sure you can tell that this is a proper fraction. You tell that 5 out of 2 is an improper fraction. You tell that 2 and 7 over 8 is a mixed number. 2.5 is a mixed number. I'm sure you'll be able to classify that today, and you remember it even as you get into your exam room. Now, I want us to look at how we can change the improper fractions to mixed numbers. We have 5 out of 2 there. That is our improper fraction. We have 5 out of 2. This 5 out of 2 can be changed to a mixed number. What are the steps? We are going to divide the numerator by the denominator. Now, we can divide. 5 divided by 2, we get 2. Our remainder is 1. And that remainder is expressed out of our denominator. So, we are saying 5 over 2 is equal to 2.5. It means here we've got 2 wholes and a half. This now gives us our answer as a mixed number, meaning we have changed our improper fraction to a mixed number. We still can change the same mixed number back to an improper fraction. We have 2.5 there. We want to change this 2.5 to an improper fraction. What are we going to do? What are the steps? Okay? We are going to multiply first our denominator by our whole number. 2 multiplied by 2, that gives us 4. And then we add the numerator, which is 1. And all this is expressed out of our denominator that we have there. Okay, we are now adding 4 plus 1 gives us 5 out of 2. That is our improper fraction. We have gone back to our improper fraction. I'm sure these are just simple steps that you also can follow, and you use them as you do your work whenever you are dealing with fractions that will demand that. Then, I also want us to remind each other of equivalent fractions. Do we all remember what equivalent fractions are? How will you define an equivalent fraction? Are you going to say equivalent fractions are fractions that are equal? Equivalent fractions are fractions with the same value. Okay, I'll give some examples here. I have 2 out of 4. I also have 4 out of 8. I have considered these two to be equivalent fractions. I've considered them to have the same value. Why am I saying so? I may reduce this one by way of dividing. It will give me 2 out of 4. I may increase this one by way of multiplying. It will give me 4 out of 8. Right. Whenever we are working with equivalent fractions, we can find equivalent fractions by way of multiplying or by way of dividing. I'll still consider 2 out of 4. My question will be divide to find the equivalent fraction of 2 out of 4. What am I going to divide by? I'll find the common factor of these two numbers. In this case, the common factor is 2. So I'll divide by 2 out of 2. What do I get there? I'm going to get 1 out of 2. So I have used the division here to find the equivalent fraction of 2 out of 4. I can also use the way of multiplication to find equivalent fractions. Right. Let me have 2/3 there. I'm supposed to use multiplication to find the equivalent fraction of 2 over 3. I can decide to multiply by 2 out of 2. What will I get? I'm going to get 4 out of 6. I may decide to multiply by 3 out of 3. What am I going to get? I'm going to get 6 out of 9. Okay, these are equivalent fractions. Before I end this lesson, there is one thing that I want us to remember. Whenever we are dealing with fractions, especially in addition of fractions, division of fractions, multiplication and subtraction of fractions, we should remember that our answer should always be left in its lowest term. How do we do that? You find that you're multiplying your fraction, you are adding or whatever operation you were using, and then you remained with 4/6, right? You remained with 4 out of 6. This is supposed to be reduced to its lowest term by way of dividing. I'm going to divide by the common factor. In this case, the common factor of 4 and 6 is 2. And this is going to give me 2 into 4, I have 2. 6 divided by 2, I have 3. My answer will be correct like that. As you approach your exams, you'll find that maybe in your PSLE paper, your answers will be like this. The first one has given you 4 out of 6. B has 2 out of 3. Why have they put these two together? Because these two are equivalent. The correct answer in this case is going to be B, because B has been reduced to its lowest terms. For today, we are going to end here. As we meet tomorrow, we will continue to look at more concepts in fractions. Thank you very much. Have a good day.